Okay, time for another video on how the simulation technique works. In this particular case, we're going to be looking at two proportions. So here we go. Let's talk about simulating the difference between two proportions. So in the two proportion setup, you have one group. Let's just say, for example, so I can assign some numbers to it, that this group has 40 people. And 9 of those people are in one particular class. So these people might be smokers, for example, and the 9 people might be, well, let's say the 40 people are smokers that are new mothers, and the 9 people that are marked with the blue dots here are mothers that had low birth weight babies, for example. Then you've got another group of people, let's say, for example, again, so I can assign some numbers to it, 68 people. Let's say these 68 people are non-smokers, and 11 of the people in this class had low birth weight babies. So the question that we have here is, are the two groups really different? And if that's the question, then the null hypothesis is gotta be, well, no, the two groups are just the same. The null hypothesis is always a statement that there's nothing weird going on. So in this case, that means we assume that there's no difference between the groups whatsoever. Well, if that's the case, then the first thing that we do is pool everybody together. Now, pooling talks about taking both groups and just lumping them into the same group. In other words, throw them all into the pool. So now I've got a group of 108 people where the 9 mothers who had low birth weight babies from group 1 and the 11 mothers who had low birth weight babies from group 2 are all just kind of thrown in there together. So all the smokers and non-smokers are in here together, and what we get is the pooled proportion. If we're assuming that the two groups are equal, then by pooling them together, that means we've got 20 people out of the 108 that are going to have low birth weight babies, for example. Or more generically, we've got 20 people out of the 108 that are going to have all the same feature. The two groups just don't matter. Okay, so here's how a random simulation works. We drew a group of size 40 and found 9, and a group of size 68 and found 11. So we're going to take the we're going to take the pooled data, and we're going to first shuffle it all up. So I've got the same 20, let's say, mothers here that had low birth weight babies, and shuffle them all around in the group of 108. And then I choose 40 of those at random. So now I've got a group of 40 and a group of 68. The ones that are not circled in red are my group of 68. The ones that are circled in red are my group of 40. Then I can calculate the two proportions. If you pause the video and count, hopefully I counted this correctly. In group 1, in the red circles, there were 8 that had the blue dots there that all had the same feature. So again, these would be like 8 that had low birth weight babies. And then the other 68 people, the ones without red circles, there were 12 that had low birth weight babies. So in this random reshuffling of our pooled data, I got 2 different proportions, 8 out of 40 and 12 out of 68. And the difference between those two proportions is 0.024. So let's pause and think here before we do any more. Going back, I have all of the data thrown together, presuming that there's no groups, shuffled the groups together, drew a random sample of the same size that I had for group 1, which then meant I had a random sample of the same size I had for group 2, calculated proportions, and calculated the difference. This difference is based on the assumption that the two groups are the same, that I can shuffle them all together. Now, in the one group the one random simulation I had, the difference in proportions by random chance was 0.024. So I had 2.4% more in group number 1 than I had group number 2. And so I put that dot on my sampling distribution. And now, with random sampling, we use a computer to do this thousands and thousands and thousands of times and we end up with the full sampling distribution. So this is how random simulation works for two proportions, and really the difference between two proportions.